first explore the different purposes of sampling. The main purposes are twofold. First, the purpose is to create a microcosm of the so-called universe. You want to create a smaller version of a population or universe, and this smaller version should be as similar to the population as possible in its structure. This should apply, just to clarify, it should apply to both observed variables, things that you measure in your sample, and unobserved variables. That's things that you don't measure, but nevertheless can have an effect on things that you measure. The known and unknown distributions of the population should all be structurally similar. So not only should our sample have the same share of males and females relative to the population, but also unknown features like their score on a measure of altruism that we don't measure, but also this unknown distribution should match between the microcosm and the universe as well as possible. For unobserved and unknown properties, we can't even explicitly test that. It's unobserved. So it needs to be ensured by the process or the procedure that we pick. Example, if we want to predict the outcome of an election with a survey on election day, very common problem, we want the 1,000 respondents we pick, which is the sample, to be representative of the Norwegian population, the population or universe they should stand for. So the sample is the microcosm here, and the Norwegian population is the universe. This means that the composition of the sample should be as similar as possible to the population. Since we don't know the distribution of voting intentions in the population, because that's what we want to find out, we need to ensure representativeness of the population by process rather than in a direct test. Okay. Okay, but there's the second purpose of sampling, which is to create diversity and variation. So the data should have not only some variation on the variables that you measure, on the characteristics that you look into, but meaningful variation. This means that there needs to be some variation in the first place, and that is because quantitative analysis get their information from differences between the different units. And this is why they need variation. If there's no variation, there is no information that we can utilize for statistical analysis. And then, if we have variation, it needs to be meaningful. What does that mean? Let's look at an example. Researchers try to clarify the role of age in physical fitness. But if you approach such a research problem and you use a sample of people aged 19 to 23, so with a very restricted spectrum of age will be much less significant a predictor than in a general population sample where age-related physical decay figures much more prominently. So there we have variation in age, but it's not necessarily meaningful variation. The variation in physical fitness and in age, both, will be much less informative in the sample with a narrow age range. Okay? Good. Just to clarify one more time, what is a microcosm sample? It's the representation of a larger population through a structurally similar selection, the sample. We want our sample to be much smaller and more manageable, but just a version of the large and unhandy population. And we call that a microcosm here. That would be exactly this. Hope that we can pick 1,000 Norwegian citizens, ask them about their voting intentions, and then infer that it's the same for all Norwegians rather than surveying the entirety of Norwegian citizens. Okay, so where are microcosm samples typically used? Microcosm samples are typically used in quantitative studies because they are particularly useful if one wants to make general statements about either distributions of certain characteristics or about the distribution of distribution of a certain characteristic in the population, or the correlation or correspondence between two or more characteristics. That would be bivariate analysis or multivariate analysis in a population. Okay, the steps when sampling from a population can be imagined as per this graphic, where first of all we define a population. We say who are the people we want to say something about, or what are the texts we want to say something about, or the phenomena we want to say something about. Then we make some practical simplifications in that population, right? Because, for instance, some people are just notoriously hard to reach, people who don't have permanent addresses, for instance. So we define a target population that would be the people who have a registered address in the country. Say this is the population of Norway, and this is the people in Norway who have a permanent address that is registered with the Folkeregister. So we may drop people who have no permanent address, or in this example, people who have no phone that's registered under their name. Then, once we have this target population, we can compile the actual list of units that we could sample from. So we represent this target population in a so-called sampling frame. There we might lose a few more people. People who haven't registered their phone but have a phone, they might not end up in the sampling frame because we rely on the mobile phone contractors, right? Or the mobile phone, the telecommunication companies to provide us with the numbers. Let's say we have the sampling frame, and then the actual process of drawing the sample occurs. From this sampling frame, we draw some sample. That means, in the best case, we randomly select elements from the list. And therefore, there should be a structural similarity between the sample we pick and the sampling frame we pick them from. And if there's not too much loss in this stage and in this stage, we would hope that we can't only say something about the sampling frame, but also about the population behind it. And the practical simplifications and the compiling of the list didn't produce significant or problematic errors. So we have the sample and we analyze data based on the sample and make statistical inferences on the inference population. So that's the people these in the sample actually stand for. It's basically the sampling frame. People who have successfully registered their phone, those are represented by the sample and are the inference population. But maybe we also have some losses here. Then this inference population and the sampling frame can differ as well. And if we try to infer back from the inference population to the initial definition or intended population, then we talk about inference errors.